Okay, so I am audible to everyone. Okay, okay, okay. Thank you. So, if you have any inquiry or something, you did not get the point or something, then you can write in chat box. So, I'll tell about that. Okay. So, welcome everyone. So, good evening. I am Subhankar Mandal, and I am one of TA of this NPTEL online certificate course, which is Analytical Chemistry. And this course instructor is Professor Devashish Rai from IIT KJP, and I am from Indian Institute of Science. So, in this live session, basically, we'll discuss about some question answer related to this course. And in this course basically I will not tell about whatever professor K taught. So I will discuss about some problems, and behind that, if any concept is there, what are the concept, so that things I will discuss. Okay. So and this is the outline of this course. So this is a 12 week course, and with every week I think you'll get some study material or some online video. So after that we'll discuss some question related to that week videos. Okay. And in this first week, basically, if all people have watched the video, then basically Professor have discussed or we have learned the basic introduction of analytical chemistry, and what are the importance of analytical chemistry, and how we can use this analytical chemistry knowledge in different field, not basically on the chemistry field, but also in physics as well as engineering and some other field also. So, and in lecture one, professor told about the significance of the analytical chemistry, and other four lecture he taught about different type of methods and different importance of the analytical chemistry. So on that basis, I will discuss some question related to these five videos. So this is the first question, where the question is filling the blank with the suitable options given below. So what contains food supplies nitrogen in our body? Okay, so there is four option: vitamin A, proteins, carbohydrate, and fats. So before doing this question, we have to know that that compound can supply the nitrogen which contain the nitrogen. So to get to know this answer, we have to think about different formula of this compound. So if you know what is the formula for vitamin A, then you will get to know that which can supply the nitrogen. Okay. So if you see the vitamin A, the formula of vitamin A is, just a minute. Mm, I think so. Vitamin A, the formula is C20H30O. So in this formula, you can see that there is no nitrogen containing group. Nitrogen containing group or nitrogen element is not there. That means this vitamin A cannot supply the nitrogen in our body. So that means A cannot be the answer. So proteins we can think. So proteins is basically the combination of different amino acid. So combination of different amino acid. Okay, so these amino acid basically different three types is amino acid is there. Okay, so one is acidic amino acid, one is basic amino acid, and other one is neutral amino acid. Okay, so if you see the general formula for amino acid, so the general formula is RCH, COOH, and NH2. So here you can see the nitrogen group is containing, or nitrogen element is there. So that means this protein can supply the nitrogen in our body. So the answer is B. So we have to check these two can be an answer or not. So carbohydrate, the general formula for carbohydrate is CN H2O whole N. Okay, so here also you can see there is no nitrogen. That means this cannot supply the nitrogen. And fat, the general formula is CN H2N O2. Okay, so that means this fat also cannot supply the nitrogen. So the answer is B. Okay, so if you have any question, then you can ask, write in the chat box. So we will go to the next question. So the next question is, what type of method is the spectroscopic technique? So there is four option is there. One is instrumental, other one is radioactive method, other one is gravimetric method, and other is titrimetric method. So basically spectroscopic technique, basically the interaction between the electromagnetic field. So interaction between electromagnetic field with the matter. Okay. So, and in this electromagnetic field, basically in spectroscopic technique, some energy source is there, some particular wavelength energy source will be there, and with that energy source, some electromagnetic field will form, and that will interact with your matter. So that is the spectroscopic technique. Like different type of spectroscopic technique is there, like NMR or nuclear magnetic resonance. So EPR, electrons, paramagnetic resonance spectroscopy. So different type of spectroscopic things is there. So if you analyze some analyte, then you have to use some instrument where you can measure the property of your compound. So this is spectroscopic technique, basically the instrumental method. And this gravimetric, basically the change of your analyte, means change of your mass with the with some parameter, like some temperature or pressure, that kind of thing. At titrimetric, you know that in school life we used to do some quantitative or qualitative analysis, where we use some chemicals on the conical flask, and we used to put on chemicals from the burette. So that is the titrimetric technique. So basically the spectroscopic technique in the instrumental based technique. Okay, so we'll go to the next question. So the question is, what is the correct statement for reducing agent? Okay, so there is four option is there. So reducing agent, before going to reducing agent, I want to tell that okay, what is the oxidation reaction and what is the reduction reaction. So what is the reduction reaction? Okay. Okay. What is the reduction reaction? Okay, so reduction reaction basically the gain of electron. So if some in some reaction some element or some compound gain electron, then their what is called the oxidation state. Suppose it is in +3 state and it will go to the +2 state. Then that is the reduction. Basically the gain of electron. Okay, gain of electron. And oxidation. What is the oxidation reaction? Oxidation reaction basically loss of electron. Okay, so now I get a reducing agent. Basically the reducing agent means who is going to reduce some other element and itself oxidize. Okay, so it can reduce other element or compound and itself oxidize. Okay, so if you take some example, that suppose Fe3 plus, I have added some compound A and it is forming Fe2 plus. Okay, so that means if here you can see that Fe3 plus accepting one electron and it is going to Fe2 plus. So A is transferring one electron to Fe3 plus and it is transformed to Fe2. So that means A is donating electron. Okay, and as it is donating one electron, that means it is oxidizing. As I have mentioned that loss of electron means oxidation. So A is oxidized. Okay, so basically the what we get to know that A is donate electron and it is oxidized. So and if you see the Fe3 plus, it is higher oxidation state. So it go to the lower oxidation state. That means the oxidizing species is accepting the electron. Now we will see the option that it has a higher oxidation state. No, if it this point cannot be, because suppose we'll take one example. Suppose manganese system, manganese different oxidation state can be possible. So manganese +7 oxidation, +5 oxidation state, and +4 oxidation state suppose. So if it is higher oxidation state, then it cannot donate electron easily. It can accept the electron easily. So this cannot this A option cannot be the answer. So it second option is it withdraws the electrons. So it withdraws means it's accepting the electron. So that cannot be the answer. So C is it reduces oxidizing agent by donating electron. It reduces oxidizing. Yeah, here I have seen that Fe3 plus is the oxidizing agent which going to the Fe2 plus, and by donating electron. A is donating electron. So C is the answer. It gets reduced itself in the redox reaction. No, it oxidizing itself. So 4 is also is not the answer. So C is the answer. So if any, I think in the end of class suggested some book for analytical chemistry. Sure, sure. I'll tell about this the book name. So from where I am doing all these problems, and from where you will get to know the concept behind all these things. So that things I'll suggest, or I'll share the PDF file. Maybe they will provide you the link in Google Drive, so you people can access that things. Okay. So we'll get to the next question. So choose the correct option given below for the absorption spectroscopy. So, okay, going to the absorption spectroscopy, there I think if people have watched the professor video also, so their absorption spectroscopy he has mentioned Beer-Lambert's law. So, Beer-Lambert's law. So basically, what is suppose you have some basically this is absorption spectroscopy for you will see the UV visible spectroscopy also absorption spectroscopy. So suppose you have one analyte in a cuvette, okay, and you have some source. If you see for UV visible spectroscopy, there is some deuterium source is there. So and suppose your initial energy is I naught, and after absorbance it is coming suppose in the detector I. So then what is called the Beer-Lambert's law says that the absorbance basically the log of I naught by I. So this absorbance is proportional to the concentration of your analytes. So whatever analyte you have used, that is suppose C concentration, then your absorbance is proportional to your analyte concentration. And if this is the length of the path is L, then this absorbance is proportional to your length. Means if the absorbance length is high, then your absorbance value will be high. So if you remove this proportionality constant, we will use some constant that is epsilon Cl. Okay. So this epsilon nothing but the absorbance coefficient. Coefficient. Okay. Sorry. No, if you use I by I naught, then yeah, there should be some negative value. So basically, if you use transmittance is equal to sorry transmittance is equal to I by I naught. So if you transform absorbance, that one it will be if whatever you are telling that is true, but that case basically minus log of I by I naught. Okay. So you just check once, maybe it will you will get to know. I think this is log I naught by I absorbance is equal to. Okay, so these things is there. So in this now, if your concentration or color compound is there, if your key concentration is high, then your color intensity will be high. So if you now you see the option that absorbance is inversely proportional to the color concent intensities. That means your concentration basically it is telling. So means your concentration is high, then your absorbance will be inverse means low. That is not the true. Where we can see that absorbance is directly proportional to the concentration. So that cannot be the answer. So absorbance is inversely proportional to the concentration of the species responsible for the color. So that also inversely proportional to the concentration, that is also not. So absorbance is directly proportional to the concentration of the species responsible for the color. Yeah, that is the key true. And other thing is absorbance remain constant with the concentration of the color. So you can see that if C is increasing, then absorbance also will be increased. Okay. So the sorry, I think this is the answer. This is not the answer. Okay. So this is on thing. So we'll go to the next problems. So if you have any inquiry, you can write in chat box. So when do we use the buffer solution? So basically buffer solution, we first get to know what is the buffer solution. So buffer solution basically is some mixture of acid or base and its conjugated salt. Okay, so that is the buffer solution, and it resist the change of pH of a solution if small amount of alkali or acid is added. Okay, so there is two type of buffer solution. One is acidic buffer solution. Other one is basic buffer solution. Okay. So and this is if you get one what is called one example. Suppose this is okay, one example. Suppose acidic buffer solution. Basically, acetic acid is our acetate buffer. So in acetate buffer is acetic acid. So if you acetic acid, so CH3 C double O minus plus H plus, and its conjugated salt C double O, suppose Na. So what will there? So CH3 C double O minus plus Na plus. Okay. So and this is the thing. Then suppose you have as I have mentioned that if small amount of alkali or acid is added in the solution, then it resists the pH of the solution. Means it resists to change the pH of the solution. Okay, resist the change of pH. Okay. So that means suppose I have added 1 molar HCl. Okay, that means basically I am adding the H plus in the solution. Okay, so when H plus will added, so in the salt there's H3C double O Na plus H plus. So basically acetic acid will form. Okay, and suppose you have added some NaOH solution, 1 molar NaOH solution. That means you are basically adding the OH minus. So when OH minus you will add it, so CH3CH plus OH minus. So what will form? CH3C double O minus plus H2. So basically whatever it is forming on the solution, that is acetic acid or it is water. So this acetic acid is a weak electrolyte. Weak electrolyte or weak acid. So for this, yeah, whatever pH is there, that will not change abruptly or something. So means basically this buffer solution is resist to change the pH of the solution. Okay. So if you see now the point option, to make the solution basic, so that is cannot the correct. To make the solution acidic, as your pH will not change so much, then your acidity or basicity will not change. So that means if you add on the pH, what is called in buffer solution, you add some alkali or something, then your pH will not change. That means solution will not acidic or basic. Okay, so to prevent the solution's pH change, as I have mentioned in the definition, that it resist to change the pH, so C is the answer, and none of above, that cannot be the answer. Okay, so in next question is, so I think someone okay, Deepika, she has written that weak acid plus salt, weak base plus salt. Yeah, it's true. Weak acid plus salt. Yeah, I have also written this one, weak acid plus, this is weak acid plus this conjugated salt, that is sodium acetate. Okay. Sir, buffer solution is prepared in situ, or it can prepare long time before for use? It's better to use freshly, because when you will use for make the buffer solution, so that time it's not means whatever pH acetic acid you can take. Suppose you make 1 molar acetic 1 molar acetic acid you have taken, okay, and that's corresponding salt you have taken, or suppose 1 molar, and you make in the mix in solution, then you measure the pH by pH meter. So pH meter you can check that this is as it is a acidic buffer, so its pH will be less than pH 7, that is the neutral pH. So for acidic vapor, I think its pH around 5.8 or something. Okay, so that you can make what is called to mix these two salt as a what is called corresponding ratio. Okay, and if what is called for pH buffer, basically if you study some protein molecule or something, then your pH will be some buffer, for buffer pH will be some pH value. Okay, if you use means keep for long time, then what is called your carbon dioxide, air or oxygen, that will dissolve in your solution. That case what is called your pH may be changed little bit. So it's better to use fresh solution every day. Okay, so this is one question is, why does the color of FeSCN whole 2 plus each solution appears red? Okay, so these things I think basically if you see some color, so when some compound is absorbed, their conjugated or corresponding color, so that time their what is called corresponding color it is absorbed, and its corresponding color it will show. So basically if we see the color circle, basically if we see the color circle VGO, G, color formation due to the change of transformation complex. VIBG, I forget the VIBGY. Oh, yeah. Oh, so this is bluish green, and this is GI. Okay. So this is the color circle. So whatever means if it is absorb the blue color, then its conjugated color corresponding color orange. So it will show the orange color. Okay. So it is written that why does the color of phthalate solution appears red? So it is showing red means its corresponding color is green. So it is absorbing the green color wavelength light. For this it is showing the red color. So if you see that complex added red radiation to the solvent, so that cannot be the answer. Complementary color, so I have told the corresponding that is complementary color, yeah. So absorb in complementary green region and transmitted red key component, yeah, that is the answer. So means basically the green key region color it is absorbing, and the transmitted it is red color. So the answer is the B. So absorb in the red region, if it is absorbed in the red region, then it will transmit it on the green color. Okay, so this is not the answer. So none of above, that is also not the answer. Okay, so Somodev have written that color formation due to the charge transfer complex. That's charge transfer complex. Yeah, that can be key also key the answer. But in the key question, there is no key charge transfer complex is there. So basically, whatever Somodev is telling. So suppose Fe key 2 plus state is there. So and it is suppose sulfur Cn. So this sulfur is as lone pair is there. So that can transfer the charge to the Fe2 plus state. So basically ligand to metal charge transfer is forming. So for that also color can be formed. Yeah, that's also can be key answer. So 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 DD transition means I also don't know exactly which key transition is forming. So I'll check that things. But as here is sulfur is lone pair is there. So and it can be possible that ligand to metal charge transfer can be possible. Okay, so exactly I don't know what means transition is key going. So I will check that okay, what exactly what transition is happening. So then I'll respond in the chat box. Okay. So any inquiries there? So, okay, then I'll discuss the okay, another problem. So, what is the potential value for standard hydrogen electrode? So, is I think all people know that the answer is zero. So, before I just want to discuss here that how the standard hydrogen electrode is there. So, basically, if you see, basically 1 molar HCl is to solution 1 molar HCl solution is to there, and when one platinum wire will be dipped on this 1 molar HCl electrode, and then what is called in this one on gas purging line will be there, where this 1 atmosphere hydrogen gas will be purged in this solution. So it's purging continuously, and it's maintain the atmospheric pressure for 1 atmosphere. So and at this potential, whatever potential will be there, that is means scientists are taken as a one on what is called 0 volt as a potential. So with this standard potential, all the potential for different compound or different electrode, whatever reference electrode you use, that is we have measured or considered. So this hydrogen electrode basically one of the reference electrode. Okay, reference electrode. Okay, so and key other potential we can key what is called we means for different reference potential reference electrode is there like AgCl reference electrode which potential is around I think 0. Plus 0.197 or something. So volt versus SHE means standard hydrogen electrode. So basically, this hydrogen standard hydrogen electrode basically 1 molar HCl solution is to taken in a big some container and one platinum where is there which is a noble metal. So this pH or some any reaction is happening on the platinum electrode surface. So as a result, these things means its potential remain constant as the any reaction or something is not happening. So as a result its potential remain constant, and this is the we means we consider this potential as a 0 volt and standard potential. Okay, so this is the thing I think today I want to discuss up to this point only. So I actually this as this is the first class, so and this is basically some introductory class for this I did not discuss so much problems. Actually I know uh, some suggestion that this way it is okay or I have to change some other way means if people can suggest that this session is okay or means I have to change that. Okay, you can discuss some topic so that we can get to know more about that topic, or we can discuss only the problems related to that topic only. Okay, so you people can open your mic or you can write in the chat box. So I don't know how many people is there in the group. So if you have any inquiry, then you can tell now. Yeah. Okay, okay, okay. Means okay. Then I can do one thing that means in that week in that week whatever professor will taught, so among these I'll choose one topic or something, then I'll sorry. Okay, okay, so that way I also can do. Just a minute, I just note that thing. Topic, okay, then other people can say what will be the other way. Okay, other things want to know that means whatever video for this week. So if people get on that week, or if people can access all the video at a time. Hello. Oh, means you can get access to all the video at a time. Means for 12 week you can get the, because means actually means there is when means I just prepare this slide so that time means I feel that some topic which is not related exactly this topic. So means maybe if you see the introduction part outlook, so there is so many things is there like a spectroscopical method and see electrochemistry method and spectroelectrochemistry. So all these thing is there, but as it is in introduction plus first week, so means I did not put so many things in first class. So maybe in later whatever more details on the topic will be there. And other things is there is different basic technique is there, like whatever we have learned from 12 standard or 10 standard to at the research level. So basically the last some portion, this electrochemistry part and bioanalytical chemistry, so all these things little bit advanced level. So for this means I am not putting that part in the introduction class. So for this I want to know that this means in this class only all are BSc level student is there, or plus 2 10 plus 2 state level student also there. As it is mentioned in yes, yeah. Okay. Okay, you are from general chemistry. Okay, so means in the course it is written that BTech student and BSc student will be there, and MSc student also will be there. Okay, there is no issue. Means on that basis only I will put the problem, so that means it can be a advanced level, or means I am planning that whatever professor will taught that things I will not discuss directly, maybe because whatever means the professor will taught very nicely. I also watched the video, so he taught very nicely, and I think that is enough for understanding. So I will only discuss some problems related to that topic, and maybe some what is called competitive exam question, maybe if I get the time. So that things I think it will be better, because as it is analytical chemistry, so there is different analytical means geoscientist or different type of things is there. So that related exam question if I get, then I would like to discuss also that kind of question also. So and if you have any question or any inquiry, then you can write in the chat box, so that I can see later also, and I can reply in that chat box. Okay. And other things is I what is called I will share all this whatever I have discussed today, and all this part, if anything means study material from where you can uh, read all these things, so that things also I will share with Google Drive link to the PMRF office. So I think they will share the link to you people. Okay. So can anyone tell that okay, how much strength of this class? Okay, I think okay. Oh, okay, okay, okay. Other things is whatever means I get the means whatever they have told that I will not discuss the question from the assignment whatever they have given. So if please don't ask the question from the whatever assignment is there. Okay. So means I can see the assignment, and maybe I will discuss that related question in different way, so that you people can solve the question easily in the assignment. Okay. if anything is there, means if people have any suggestion that sir you can means discuss all these things in different way, then you people can tell. Okay, okay. Actually, I also feel that question level is quite easy. Actually, in the introduction class, there is means nothing is there. So means only introduction class. What are the importance is there? That things is there. So for this, I have keep the question in basic level. So means I know that all people know all this thing. So means I'll maybe next week I'll improve the question level. Okay. Okay. So if any other things is there. Okay. So I think if people don't have any inquiry, then I think it is as they have told for 1 hours. I don't think that for 7 minutes we can discuss something. So I think. Okay, book. Okay, I'll share all the book details. I think means I have two, three books on analytical chemistry. So that Google Drive link I will share. Okay. So then I think that will be good. Otherwise, if people can study some standard analytical chemistry book. So, and I think this last question, the standard hydrogen electrode, there is some reference book is there. I think I forgot the author's name. So means all the reference electrode. I forgot the name. So that part means whatever standard electrode, hydrogen electrode is there, that part I will share the PDF. Okay. So I think that will be the good. Okay, then I think we can call off the meeting. I don't know if you have some other inquiry also, you can tell. So in this class, the assignment when you people have to submit. So is there any means deadline for submission the assignment or something, means for every week you people have to submit, or is there some deadline? Okay, 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 no issue. Okay, yeah. I think there is two TAs there for live session. I think one is Tuesday and mine is okay, Friday 6 to 7 p.m. Okay, so every Friday 6 to 7 p.m. I have the class. I think in same link, if people can join the discussion class. Okay. Oh, in 6 to 7 you have another class. Okay, okay. So if you can it is called inform PMRF, sorry, this NPTEL office, so they might do something. Otherwise, what is called, I will share all these video, whatever I have discussed. So I think you can get all the information from that video. And okay, okay. Other means you get the mail, what is called video of this session. So I hope it won't be any difficult to get all the documents and study material, all these things. Okay. Okay, then shall we call off the meeting? Okay, thank you everyone for joining. Have a great week. Okay, thank you. Sorry. Yeah, sure. You can, you people can leave the meeting. Thank you everyone. Why